morning, students. Today in this lecture, we will study about the biserial and point biserial correlation. I am Dr. Jai Singh from Vasanta College for Women, and in this lecture, we will study about some new methods to find the correlation, that is biserial and point biserial correlation. But before proceeding to the biserial and point biserial correlation, first we will discuss about the Pearson correlation method and Spearman rank order correlation methods. Rank order correlation method is based on the rank in which the variable is not normally distributed and it is not of the continuous nature. And the variables in rank order correlation methods may be measured on the ordinal scale, but in the second method, that is the Pearson method, both the variables between these two variables, if we are interested to find the correlation or strength of association, then these two variables should be normally distributed and continuous nature. In a large group of the data, both the variables should be normally distributed. The main assumptions for the Pearson correlation method is that both the variables should be normally distributed and continuous nature. But what is the difference? In some other cases, if the first variable is of continuous nature, but the second variable have some dichotomy, it means the second variable can be separate into two parts, or its nature is of the dichotomous type, then Pearson correlation method should not be used. And in such case, biserial and point biserial correlation method should be used. Biserial and point biserial correlation method, both methods are used to find the correlation between traits and other attributes similar to the Pearson method. But the second variable, if this have the dichotomous, it means separated, it can be separated into two parts, then biserial and point biserial correlation methods are appropriate. Suppose for an example, if we are interested to find the correlation between mental ability and social adjustment in a group of nursery children. In this case, the mental ability is of continuous nature, means first variable is of the continuous nature, and social adjustment is also of continuous nature, but it can be divided artificially, it may be divided in two parts, and these two parts may be socially adjusted and socially maladjusted. In such case, Pearson method is not appropriate and biserial and point biserial methods may be used. But later we will discuss when biserial method should be used and in which case point biserial correlation is an appropriate method for measuring the association or strength of association between these two variables. But before proceeding to the biserial and point biserial, first we should understand the nature of the variable in context of the dichotomy. Dichotomous variable means the variable can be classified into two categories. If a variable can be classified in two categories, then its nature is dichotomous. Dichotomous means to cut into two parts. There are some examples of the dichotomous variable like male and female, dead versus alive, and if any statement is asked and there may be two responses, that is true or false. And similarly, any problem may be on which the response can be categorized into two parts, that is passed and or failed. And in some personality inventory items, two responses may be yes or no. And similarly, in interest items may have two responses, like or dislike. And similarly, pass versus fail, and this may be based on some cutoff score on a test. On based on the some criteria, we can separate into two parts. Some student may pass and some student will fail. Similarly, some students may have less height, short, and some may have high heights, that is, they may be tall. And this may be divided based on the arbitrary height. Other examples of the dichotomous variable may be adjustment variable, and the two dichotomous categories may be socially adjusted and socially maladjusted. In the group of the athletes, some may be athletic and some non-athletic. Similarly, some people may be radical and some may be conservative. And in the study, in the classrooms, there may be some students who drops out and some stay in. And if we find some people may be socially minded and some may be mechanically minded. Similarly, we can divide into two parts to the students: seventh grade and above and below the seventh grade. So, in such type of the variables in which we can separate group into two parts, then its nature will be dichotomous type. Dichotomy means we can cut into two parts. There are two categories of the dichotomous variables. Based on this discussion, we can say that two types may be. One is the discrete or true dichotomy, like male and female. There is no continuity in this variable, and naturally they are divided into two parts, that is male and female. So gender have two categories, male and female. But in some examples, in some cases, dichotomous will be continuous or artificially created. Based on some criteria, we divide the variables, the measure of the variables into two parts, and in this case, the variable will be continuous type, but artificially we can divide into two parts. So these two types of the dichotomous variable may be in these cases. Now we will differentiate between the true dichotomy and artificial dichotomy. If the variable is of discrete nature, it means there is true dichotomy. It means there is no underlying continuum between the groups. Some examples are male and female, dead and alive, dropouts and stay in, problem passed or failed, and based on the statement, responses are true or false. And personality inventory items, two responses may be yes or no. Seventh grade, above and below the seventh grade. And interest items, response may be like or dislike. These are the examples in which there is true dichotomy, or this is the discrete nature. But opposite to this, there may be a dichotomy, but dichotomous variables are made on the based of some criterion, and this is continuous or artificial dichotomies. Continuous and artificial dichotomies are those which we assume there to be an underlying continuum, but we assign individuals to a category based on some arbitrary criterion. And the examples of such type of the dichotomy are pass versus fail based on some cutoff score on a test. Short versus tall, height is continuous variable, but based on some criteria, we divide it into two parts, short versus tall. Then this is artificial dichotomy. Some more examples of continuum artificial dichotomies are adjustment variable, and the two categories are socially adjusted and socially maladjusted, athletic and non-athletic, radical versus conservative, socially minded versus mechanically minded, pass versus fail based on some cutoff score of on the test, and short versus tall. These are the examples of the artificial dichotomous. Now we come to the biserial and point biserial correlation. If the dichotomy is of a natural type, then point biserial is used. But if we artificially made the dichotomy based on some criterion, then biserial correlation should be used. This is the major difference. This is the main difference between the biserial correlation method and point biserial correlation method. We should use the biserial correlation method only in the case of the artificial dichotomy. But if there is true dichotomy or discrete dichotomy variables are there, then point biserial is an appropriate method. Biserial correlation. What is biserial correlation? The biserial correlation is an estimate of the relationship between a continuous variable and an artificially dichotomous variable. The difference between the Pearson correlation method and biserial correlation method is that the second variable is artificially dichotomous type. And in this variable, one of the sample is measured as dichotomous, but that sample is really normally distributed. It means the nature of that variable is normally distributed, but we made the dichotomous. We assume an underlying continuum but assign individuals to a category based on some arbitrary criterion. And based on the some arbitrary criterion, we divide this into two parts. In such cases, point biserial correlation is not appropriate, because generally, and this point biserial correlation in such cases where we made artificially made the dichotomy, then point biserial underreports the true value of the association. The biserial correlation coefficient provides a better estimate in this case. If we artificially made the dichotomous, then biserial correlation coefficient provides a better estimate of the correlation coefficient or the strength of the association between two variables. Now, we should come on the formula which should be used for calculating the biserial correlation coefficient. Biserial correlation coefficient is represented by small r and subscript bis is written, and BIS denotes the biserial. R biserial is equal to MP minus MQ divided by sigma into PQ upon U, where these symbols, what they represent. R biserial, as we know, this is the coefficient of the correlation, and MP is the mean of the superior group. Means we divide into these groups into two parts. One group is the superior group and another is the second group, and mean of the first group, that is the superior group, is MP, and similarly the mean of the second group is denoted by MQ, and sigma is the standard deviation of the entire group. Here we should know that standard deviation is calculated of the total group, not the separate group. And P, small p, is the proportion of the entire group in category 1. Means this is the ratio of the numbers of the members in superior group with total numbers. And Q is the proportion of the entire group in category 2. This is the ratio of the numbers of the members in second group with total number. And as we know that the data is normally distributed, and we artificially made separate this into two parts. One portion is P and another is Q, and at the point where we separate these two groups, the ordinate of the normal probability curve at this separated point is denoted by U. U is the height of the normal curve ordinate, and in this figure we can see here that U is the ordinate and this is the height of the ordinate, and at this point this normal probability curve is separated into two parts, and higher parts, superior parts, is the at the upper end of the normal probability curve, and second part which achieve less score is in the left part or in the inferior part. Now we come to the point biserial correlation. A point biserial correlation is used to measure the strength and direction of the association that exists between one continuous variable and another true dichotomous variable. The difference here is that here true dichotomy is available, but in biserial correlation there was no true dichotomy, artificially dichotomous is made. It is a special case of the Pearson product moment correlation, which is applied only when we have the two continuous variable, whereas in this case one of the variable is measured on the dichotomous scale. It is there is dichotomy in the second variable, and the nature of the dichotomy is true and it is not artificially made. Then point biserial correlation method will be used. With the help of these two examples, we will explain this point biserial correlation. As we know that point biserial correlation is an appropriate method to determine whether there is association between, in first example, if we want to measure the association or correlation between salaries measured in Indian rupees, salary is measured in Indian rupees, suppose, and the second variable is gender, that is male and female. Continuous variable is salary And the dichotomous variable is gender, that is the second variable, which has two categories, males and females. In this case, point biserial correlation is an appropriate method. Similarly, in another examples, which generally the doctors used, is the cholesterol concentration measured in millimole per liter. Concentration of the cholesterol in the blood is measured in millimole per liter, and second variable is smoking status. Smoking status means first variable, cholesterol concentration, is the continuous variable, and it is the marker of the heart disease. In the case of the heart disease, this is measured. And second variable is the dichotomous variable, that is smoking status, which has two categories, smoker and non-smoker. Means some people who smokes, we measure the first cholesterol concentration, first variable, and also we measure the second first variable, cholesterol concentration, for the non-smoking people, and then we find the correlation. And this method is point biserial method is an appropriate method in this case. But there are some assumptions to use the point biserial correlation method. Everywhere, but point biserial correlation method should not be used. First, we should check the assumptions. If the assumptions are fulfilled, then only point biserial correlation method will be used. What is the assumption first? One of two variables should be measured on a continuous scale. First variable is measured on the continuous scale, and some examples are intelligence, as we use this in education, exam performance, which is measured from 0 to 100, weight in kilogram, and so forth. And the second assumptions is about the second variable, that should be dichotomous. And the example of dichotomous variable include gender, that is male or female, employment status, and the two categories of this variable may be employed or unemployed, smoking, that is yes or no, and so forth. Similarly, there is third assumption, there should be no outliers for the continuous variable for each category of the dichotomous variable. This is very important assumption. Outliers are the points which do not match the main points, and this is distributed at long distance, and the outliers can be tested using box plots. Box plots is a best method to find the outliers. And assumption 4 is continuous variables should be approximately normally distributed for each category of the dichotomous variable. It can be tested using the Sapiro-Weyk test of the normality, and this test should be used with the help of the SPSS software. We can check this assumption using the SPSS software, which we will discuss in any other lecture, not here. And assumption 4 is continuous variables should have equal variance for each category of the dichotomous variable. Means if we divide this into two parts according to the dichotomy, then for both the parts, the variance of the scores for first variable should be equal to the variance for the second group. And the formula for calculating point biserial correlation, here we will show you about, we will tell you about the formula which is being used for the point biserial correlation. R point biserial is equal to mp minus mq upon sigma into under root square root of p into q. Here the symbols represents R point biserial is equal to coefficient of correlation, and here the subscript is PBIS, means point biserial. It denotes the P point biserial, and R point biserial is the coefficient of the correlation, MP is the mean of group 1 and MQ is the mean of group in the second category, and sigma is the standard deviation of the entire group. Here P is the proportion of entire group in category first. It means this is the proportion of the subjects which are allotted in first group, and Q is the proportion of the entire group in